Hey class, in today's lesson we're going to talk about real zeros of polynomial functions, which is found in section 2.3 part 2. We're going to use the factor theorem and we're going to use the rational zero test to determine possible rational zeros of polynomial functions. Alright, so in example 6, what we're going to do is we're going to show that x minus 2 and x plus 3 are factors of f of x equals 2x to the 4th plus 7x cubed minus 4x squared minus 24x minus 18. Then we're going to find the remaining factors of f of x. So to show that they are factors, essentially, we can use synthetic division to divide them out, okay? So essentially the number that would go in the box for this one, shouldn't have done that. The number that goes in the box for this one, if I set it equal to 0, would be 2. So 2 would go in a box. And then negative 3, again, if I set that equal to 0, would go in a box. So if I put 2 in the box for the first one, because it doesn't matter if I do 2 first or if I do negative 3 first, they're both going to work. My coefficients, these are already in descending order from highest power to lowest power, so I can just focus on their coefficients, which are 2, 7, negative 4, negative 27, and negative 18. All right, here we go with our process. So 2 times 2 is 4, 7 plus 4 is 11. 2 times 11 is 22, negative 4 plus 22 is 18. 2 times 18 is 36, negative 27 plus 36 is 9. 2 times 9 is 18, negative 18 plus 18 is 0. We expect this last number to be 0 because if it's 0, then that means it does not have a remainder. And if something is truly a factor, then it doesn't have a remainder, so that's good, okay? Now we're going to test in our negative 3. So again, using these same terms that we just found, so 2, 11, 18, and 9, I should be able to continue to break that down by division. So negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 3 times 5 is negative 15. 18 minus 15 is 3. Negative 3 times 3 is negative 9. 9 minus 9 is 0. Again, if 0 is our remainder, then that means that what we were testing is actually a factor. So what we are left with as a polynomial, now first, let's remember, when we divided it the first time, it was left as an x cubed as its highest power. Now what we're left with is an x squared as its highest power. So 2 is actually 2x squared plus 5x and then plus 3. So if we want to continue to factor that, we should use the AC method. So if I do AC out here to the side, a times c is 6. The factors of 6 are 1 and 6 and 2 and 3. The factors that give me 5 are 2 and 3. So if I start rewriting, I'm going to switch colors so this doesn't look confusing. That'd be 2x squared. I'm rewriting this. So 2x squared plus 2x plus 3x and then plus 3 at the end. We group. Greatest common factor of the first half is 2x. We're left with x plus 1. Greatest common factor of the second half is 3. We're left again with x plus 1. So we're left with 2x plus 3 and x plus 1. And those are the remaining factors. So in total, our final answer, if we wrote everything as just factors of f of x, we'd have f of x equal to the two factors we were given, which were x minus 2 and x plus 3. And then the other two that we just found, which are 2x plus 3 and x plus 1. And that is all. So the rational zero test relates the possible rational zeros of a polynomial function to the leading coefficient and to the constant of the polynomial. So possible rational zeros are factors of the constant term over the factors of the leading term. So there can be a lot of different possibilities. And then we use trial and error to determine if they're actual zeros of the polynomial or not. So what does that mean? Well, our possibilities, first of all, remember, are the factors of the constant term. This is our constant. So the factors of 1 are just 1, okay? And it's always plus or minus whatever we determine. So plus or minus 1 over the factors of the leading coefficient. Well, the leading coefficient is 1 again, so it's still over 1. So our choices are either, if we wrote them out as fractions, it'd be either positive 1 over 1 or it'd be negative 1 over 1, which we know is the same thing as 1 or negative 1. So we're going to test 1 and negative 1 into this function to see if either one of them works. So let's test it. First, let's test positive 1. See if it is a 0 of that function. Again, we're going to use our coefficients. So the cubed is 1, squared is 0, x is 1, the constant is 1. So if I drop down a 1, 1 times 1 is 1, 0 plus 1 is 1. 1 times 1 is 1, 1 plus 1 is 2, 1 times 2 is 2, 1 plus 2 is 3. That number needed to be a 0 if it was truly a factor. So 1 is actually not a 0. Okay? Now we're going to test negative 1 using our same coefficients. Here we go. Negative 1 times 1 is negative 1. 0 plus a negative 1 is negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. Negative 1 times 2 is negative 2. 1 plus negative 2 is negative 1. Again, because our last number is not 0, then negative 1 is not a 0 of this rational function. So this one actually has no rational zeros. It does not mean that it does not have any zeros. They're just not rational numbers, which means numbers that can be written as a fraction. Okay, we're going to try it again. So again, we're going to list our possibilities first. So our possibilities, so I'm going to just say pos for possibilities. Remember, it is the factors of your constant, so that's plus or minus 3. Its factors are 1 and 3. Okay. The factors of 2 for the denominator would be 1 and 2. So those possibilities are plus or minus 1 over 1, 3 over 1, 1 over 2, and 3 over 2. Essentially, all I did is take all my numerators and rewrite them on top of the denominator. Okay, so obviously these two are whole numbers, so they really just represent 1 and 3. But then I have two fractions, 1/2 and 3/2. So to make this nicer on us, I'm going to start with positive 1. Let's just see if positive 1 is a factor. So if 1 is a factor, it should divide out evenly. Our power for our polynomial is already in descending order. So we should just be able to write our coefficients as we see them. So that's 2, 3, -8, and 3. Here we go. 1 times 2 is 2, 3 plus 2 is 5. 1 times 5 is 5, -8 plus 5 is -3. 1 times -3 is -3, -3 plus 3 plus -3 is 0. That is what we wanted. So now we should be able to continue to factor the rest by hand. What we are left with is 2x squared plus 5x minus 3. If we use AC to factor that, we'll get 2 times -3, which is -6. The factors of 6 are 1 and 6 and 2 and 3. And what will work is a positive 6 and a -1. Positive 6 and -1. So here we go. 2x squared plus 6x minus 1 minus 3. Excuse me, 1x minus 3. Okay, if we group the first two and the last two, 2x can come out. We're left with x plus 3. If I take a -1 out, we're also left with x plus 3. So our final answer is 2x minus 1 and x minus 3. So to get the rest of our zeros, not only is x equals 1 a 0, but the answer to these two factors are, if I set them equal to 0, I will have 1/2, and I will also have positive 3. So these are my zeros. And again, I got those because I said 2x minus 1 equal to 0, solve for x. X minus 3 equal to 0, solve for x. And the 1 came from the original. Okay, let's keep going. Oh, and I made a mistake. Almost. This was x plus 3. Sorry, x plus 3. That makes it x plus 3, so this makes it say -3. All right, fixed it. All right, last one, our try. It says to find all the real zeros of f of x equals 10x cubed minus 15x squared minus 16x plus 12. List all the possibilities and then use a graphing calculator to narrow down your first choice. So our possibilities, remember, are the last term, so the factors of the last term. So the factors of 12 are 1 and 12, 2 and 6, and then 3 and 4, right? So this is really plus or minus, if I put them in order, 1, 2, 3, 4, 6, and 12. Man, that's a lot. over the numerator. The factors of 10 are 1 and 10 and 2 and 5. So that's still 1, 2, 5, and 10. Because there are so many choices, what we're going to do is we're going to use our graphing calculator to graph our function and to hone in on our first zero. If you type this into the y equals section of your graphing calculator and you do second trace 0, you will see that one of our first zeros that I'm going to attempt to find, or the one I'm going to attempt to use, is x equals 2. So if x equals 2, 2 is the number that we're going to put in our box, and then we start our process. This function is written in descending order, so we're going to focus on our factors only. So that's 10, negative 15, negative 16, and 12. So here we go. 2 times 10 is 20, negative 15 plus 20 is 5. 2 times 5 is 10, negative 16 plus 10 is negative 6. 2 times negative 6 is negative 12. 12 plus negative 12 is 0. It works. What's left over as a quadratic function is 10x squared plus 5x minus 6. And then we would use AC to continue to factor. So those AC would be 10 and 6, or 10 times 6, which is 60. Really, we have negative 60. So that's 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. What happens is none of these work to give me 5. So because none of them work, then x is the only real zero of the function. So this number here is our only real number 0. Now, something else you should know. These are not the only zeros. There are actually some other zeros out there. They are just imaginary. So again, we're focusing on real zeros. So the only real zero of this function is x equals 2. The others, if I wanted to truly factor them, I could have used the quadratic formula for this to find the other two imaginary zeros. But again, the only real zero is x equals 2. All right, guys, that is it for today. If you have any questions, please see me for tutoring.